let's dive in. Okay.
We see your screen. We see a list of presentations.
And do you see my presentation now?
I'm still seeing the list of presentations.
This.
So one thing if you want to try again maybe, but if this doesn't work, one thing we had discussed while you were on is you can potentially email the presentation to Jonathan, and Jonathan will can do it for you. Oh, no, this looks good.
Okay.
You could maximize the window, that would be great. But
so yeah, I'm gonna do that to keep control.
Perfect.
Is it decent? Is it okay?
Yep.
Thank you, and sorry about that.
That's fine. Like I said, I'm sorry we have to use Meet. That's just what they pay for here.
Yeah, okay, no problem. And thank you for waiting and not switching to the other one, but you could have done so, no problem. So I asked, in fact, Ryan to be presenting first, if I could be presenting first, because the disclaimer is we don't have multi-CI in production yet. We are working on this and to have it soon. And we've done actually some work. We've been doing some work the last 2 years that I think have prepared us to move to multi-CI projects. So that's what I'm going to present today, how we prepared for this. And I'm excited to get this opportunity to get other views about how you did it, if you did it for your projects. And if you think, and what would be your answer to these questions? Is standardized CI and standardized dependency management a prerequisite to multi-CI projects, to multi-project CI? So I will be talking about the LNL Radius open source projects, so Lawrence Livermore National Lab open source projects. And just a few words about me. My name is Adrien Bernede, and I'm working for the Radius projects and using GitLab on Livermore computing systems. It's a pilot project from 2019 at the lab, aiming at replacing Bitbucket and Bamboo from the Atlassian suite. I've experienced mostly using GitLab CI and Stack to work for open source project hosted on GitHub. And I mentioned that because I specialize in using GitLab as a CI provider, but not to host projects, actually. We host all our open source projects on GitHub, and we use GitLab for the CI on the clusters we host at Livermore Computing. Also, to answer your question, Ryan, I'm open to interruptions. If you have questions, please unmute. It's easier for me to deal with than the chat, or if Ryan, you want to manage the chat, for me, that would be great, because I'm not mastering this Meet tool. Okay, so an overview of the Radius project. It's actually an umbrella project supporting more than 30 open source projects at the Livermore National Lab. And I'm not working on the CI for all of the projects. I'm working for about 10 of them. I'm involved in the CI of about 10 of them, larger or smaller. The idea is, with this kind of umbrella project, umbrella funding, let's say, it's easier to fund something like me working across several projects. And multi-CI project, multi-project CI is kind of a cross-project task per definition. So it's also an interesting way to fund such activity. We could see this as we could see my position as a research software engineer position, if you're familiar with this naming. So I think the big picture is quite similar to what you experience if you have several projects and you want to build them together. We have a fair portion of Lawrence Livermore National Lab open source softwares that ends up being used as a dependency of a large simulation code running on LC systems. So this means those separate projects on GitHub are actually used in a single, potentially in several, but in a single simulation code with a single environment and in a single dependency graph. So we need to test them, prepare them to be tested on a very tied up environment so we can make sure they will work well together when they are actually built by the users. So this is what motivates the standardized CI I'm going to talk about, the standardized build system, and the consequence of that is would be the multi-project CI, when you branch all those project CI together. A closer look at the context, I'm adding here that we use mainly two tools to achieve this. GitLab, of course, I mentioned, because we have set GitLab set on LC systems, so we can access several, if not all, the machines at Livermore through GitLab and GitLab runners. Those are specific HPC runners to address that need. And we also use Spec to describe the software stack on the machines, as well as the targets, so what we want to build in terms of compiler, variants, and dependencies. And we also use Spec to build the dependencies in the CI. So there are two aspects, the shared CI implementation and the shared build management implementation, let's say. So this is what I'm going to present right now. So we initially we had one big infrastructure, and we split it recently into really two clean infrastructures, the CI implementation, which does not require Spec. This is quite generic. It's a generic and shared CI implementation that helps projects set up a CI on LC systems. It could be used to set up CI on other systems if you add the necessary sub-pipelines. So the way it works, for each project, we need a GitLab CI YAML file to describe a pipeline on GitLab. And what we do is we are going to use sub-pipelines, child pipelines in GitLab. It's a feature in GitLab that allows you to trigger sub-pipelines in your pipeline. And we describe in the Radius shared CI repository, we have one generic pipeline per machine that's already configured for the users. And all the users need to add is job instances for those machines and specify a job command. So it's written in a generic way so that the only thing needed for a user out of the box is a job command and a job instance, meaning they can specify the script, specify some variables, or override some information. This is all customizable, but it's initially tuned for our use, but the goal was to be able to propagate this to several projects easily. So I think it's interested if you ever thought about sharing your CI implementation among projects, and I'm really interested in hearing if you're actually doing that or not. Please tell me if you are or if you're not. I'm really interested in feedback about this. Actually, at the least, it's one way to do it. The second part of our infrastructure is the shared build infrastructure. Infrastructure here is a big word, but it's a shared implementation for how we manage the build context and how we actually build the project. So as I said, we are using Spec, and in a shared Radius Spec configs repository, we have shared YAML configuration files for SPAC describing all the compilers we are interested in, all the external libraries we have on LC systems that we want to use, and we share those among projects so that we know that every project in their CI builds with the same dependencies, with the same external dependencies, with the same compilers, so with the same context, in a controlled context somehow. And we can, and of course, end users can see what we used for our testing, so they can also leverage this to be sure to build something that has been valid in our CI. The input for this build infrastructure is a SPAC spec. A SPAC spec is I mean, I see it as a unified way to describe what you want to build. So it's interesting because you can use the same spec. If you remove the project, you can apply the same spec, like the compiler, some generic variants, and some dependencies. You can apply them to several projects. So yeah, it's a generic way to describe what you want to build to some extent. And the output of this build infrastructure is, so what we build with this is actually we build the dependencies and we generate a CMake cache file. So it's like building the dependencies and stopping the build of the project itself at the configuration phase, where we configured everything from the variants and the dependencies we set. And now we provide the CMake cache file to the project for the project to keep going with the build of the to the developers to keep going with the build of the project itself. So the reason for that is to have this CI inspired build infrastructure that can be actually used by developers. So if you're a developer, you can say, I would like to build locally something like something that you can describe with the SPAC spec, and you're going to build all the dependencies for that and generate a host config file, and then you can keep going with your manual build of the project itself, fine-tuning things or doing tests. And that's actually what we do in the scripts for the CI. We let projects provide their own script where they can where they build the dependencies with our infrastructure and then can build the project and run the test the way they want. So this is left to the project to implement. So now we just need to branch those two, and the interface is only the job command, which naturally becomes the script the project has set up for the CI, and list and for the project to provide the list of SPAC specs they want to build as in the CI jobs. So really, typically when I set up a project for the CI for one project, my jobs looks like almost a list of specs, a list of SPAC specs, and all the rest is shared and generic. Now, how does this allows us to move to multi-project CI easily, in my opinion? Let's say we have project B and O. Sorry. Let's say we have project B and project C, depending on project A. They all have this CI infrastructure and build infrastructure. So their CI is split in looks like this. It has an install dependency phase managed by the build infrastructure, a build phase managed by the script, and then the project's testing also managed by the script. If we build the project A, which is the dependency, and run the CI, we can then add an additional step, which is multi-project testing, and we can trigger in GitLab, using the GitLab feature, we can easily trigger a pipeline in both B and C. And then all the remaining thing is to propagate the information that we want B and C to build with project A at custom hash or custom version. So let's say we are building A at develop because and we validate that the develop branch of A is fine. Then we can propagate trigger a pipeline in B and C and say we want to build project A at develop in both those at the dependency phase. And Stack allows you to do that very easily in the Stack spec. The only thing you need to do is to add project A at depend on project A at develop in the Stack spec. So naturally, with our setup, we have a nice way, integrated way to set up the multi-CI pipelines. There are some drawbacks. Then comes I would say the usual drawbacks of being sure you're not reporting. So if you triggered project B at develop, for example, with project A at develop, this pipeline should not report the status to your for us to GitHub, for example. Otherwise, it would override the current status of the developed commit. So this is the kind of thing you need to think about when you set up this multi-CI project. But I think it's the usual. It's usual to have this kind of thing to think about. I have other slides to answer questions about how this is implemented in more details, but this is the end of what I wanted to present to you today. And yeah, I have references and I can answer questions.
All right, thanks. Does anyone have any questions?
I'm kind of curious in that multi-project like dispatch slide that you showed. So you're changing project A, and you want to make sure that the CI for projects B and C still work. But then, do you have a way to specify like branches of B and C in case if you're making like compensatory changes in B and C to accommodate the changes in A? Like, do you have to keep track of kind of all the branches that need to be tested?
So that's a good question. So the initial way we anticipate we are going to use this, I think we are ready to use this, is for when you have a new commit in the develop branch of A, we want to make sure that B, the develop branch in B and the develop branch in C are still working. And if not, then the developers can analyze why. It's not necessarily that something is broken. It's just that they need to fix something for the next, to think about something for the next release, that there is probably a breaking change coming. Does it make sense, my answer?
Yeah, I think that does make sense. So basically, you could merge a PR into project A, even if the project B CI was showing red, because it's on.
Yes.
You basically have time before the release to fix that.
Yes, I'm not tying the status of my project A CI to this. I'm using this more than like a warning. I'm seeing this more like a warning. If you're using this to tie the status of your CI to the result of the sub project, the dependent projects, it's becoming hard to think about, I think. Yeah, but what we anticipate the next phase would be is to test this at least once for when a pull request becomes mature. We can manually hit a manual job that consists in triggering the pipeline in the sub projects to make sure to test if this particular pull request is affecting the build in the dependent projects.
Okay, thank you very much.
You're welcome.
Any other questions?